Okay, good students. We are going to do the lesson 2 homework. It's one of the most important homeworks of the year um, because you are now in charge of creating these slope equations. We learned one of our first rules of slope equations that if you have a polynomial, some sort of x to the power, doesn't matter what the number is, as long as the number is in the numerator, and if you have some function, and if you want to find the slopes of this, turns out, and we kind of saw this graphically, that the slopes are always going to be 1 degree less. But because of like the binomial theorem and Newton and mathematicians plugging in x to the n into the magical limit and slope formula generator, turns out there's a little bit more, that this power actually comes down and then we subtract 1 from the power. So it's really easy to find equations of to find slope equations, to find these f prime equations. What is a limiting factor is you guys and how strong your exponent rules are. Okay, so I'm going to be doing some. Make sure you guys try all of these yourself and you're not copying this down, because who boy do I notice you guys are weak at exponent rules and you need to practice. Now we are asked to find the instantaneous rate of change of the function at the given point. We need 2 statements, at least 2, so you don't have to write a statement for every single problem, but at least 2 statements showing you understand the meaning of what you find. Now, what is an instantaneous rate of change? It is a slope at a point. It is a slope of a tangent. Slopes equal change. Instantaneous rate of change, slope of a tangent. Or another word, derivative.
Sorry.
So we are finding the slope of this function at x equals 2. I will find the slope equation by using the power rule. 4 comes down, minus 1. 3 comes down, minus 1. Great. Plug in x's, get m's. I get 64 plus 48. And I get very large slope, but a slope nonetheless, 112. Which means, and this is my first statement, I'm going to write 2 statements. At, and you guys screwed up on your quiz on this. At x equals 2. This is not on average. This is an instant rate of change. At x equals 2, my original function, 2x to the 4th plus 4x cubed, is increasing 112 y's per x. It's going up, and it's going up fairly fast. That is the statement. Let's do another one. The slope equation, x squared becomes 2x to the 1st. The slope of y equals x is 1. The slope of 3 is 0. I'm going to include the plus 0 just so you know that the slope of 3 is 0. Now, what is the slope of this at 5? Well, this is the slope equation. Plug in 5, I get 11. Now, that's an m. It's an m of a tangent, which gives us an instantaneous rate of change. Here's my second statement. At x equals 5, f of x is increasing 11 y's per x. All right, I'm just going to start saying the statements every time. And you can write down if you want. What if you got stuff in the denominator? Don't use the power rule until stuff is the numerator. A lot of times we will have to use our exponent rules so that we can write things as x to powers in the numerator. This is x to the 1st. I move it up and make it a negative 1st power. X to the negative 1st is the same as 1 over x. X to the negative 2nd is the same as 1 over x squared. We have rewritten it. Now let's find the slope equation. The slopes of y equals 1 are 0. The slope of x to the negative 1st is negative 1 x to the, subtract 1, negative 2. The slopes of x to the negative 2nd. Y'all need to be doing this. Bring down the negative 2. Now, I like to put a plus a negative. That way I have a negative 1 here. Or you could be subtracting negatives. I like to add positives. Signs are very important in this class. mistakes are made often with just signs. So negative 2 times negative 1 becomes positive 2x to the subtract 1. It doesn't become negative 1, it becomes negative 3. Now at 2, well, I need to plug in 2, but the only way I'm going to plug in 2 is into something that is easy to plug into. I don't like negative exponents, so I'm going to rewrite it as positive exponents in denominators. The negative 1 stays, the x moves. The 2 stays, the x moves. I bet you if you're trying this by yourself, which you all should be doing, some of you are moving that 2 down. Or you're moving the negative 1 down. The 2 stays, it's not being taken to the power. It's just the x that is being taken to the power. All right, now I plug in 2 and I get negative 1/4 plus 2/8. I want you to simplify. You need to know how to add fraction. This is negative 2/8 plus, oh, look at that. This is 0. Would you look at that? Negative 1/4, 2, 2, 4, 8. I mean, I'm going to see this. Whenever I see a cool answer, I'm going to investigate. And you can investigate by graphing and just looking. And wouldn't you look at that? Right up there, we have a slope that is 0. Really cool. Okay, moving on. What do I do with 4 over x squared? Leave the 4, move the x squared up to be x to the negative second. What about x squared over 4? Now watch this. This is a very important one that a lot of students mess up on. I would rewrite this understanding fractions as 1/4 times x squared. If you had problems with this, you could always rewrite it as a fraction times x squared. This would be 4 times 1 over x squared. If you wanted to, that's 4 times 1 over x squared. But then I'd rewrite it as 4 times x to the negative second. Exponent rules, derivative rules, negative 2 minus 1. The 2 comes down. 2 times a fourth. You need to know what 2 times a fourth is. It becomes 1/2. Minus 1. Plug in 2, but maybe wait until you know how to deal. Don't move the negative 8, just move the x to the negative third. Plug in 2. You get negative 8 over 8, which is negative 1, plus 1. Oh my gosh, we get another 0. It's incredible. 4 over x squared over 4. And look at that, another 0 too. A slope that is 0. The slope right there is 0. Okay. It was late in class, but it's just something that's cool and interesting. The slopes of sine are cosine. The slopes of cosine are negative sine. Now, you see this number 2. It's like, oh, is the slope of 2 0? It's like, no, you didn't say the slope of this 4 was 0. You wouldn't say the slope of this 2 is 0. It's just a number that would stay. It's just like a constant that stays, and the slopes of sine are cosine. So the slopes of 2 sine are just 2 cosine. What about cosine x over 4? Well, I'm going to probably rewrite this first as 1/4 cos x. The slopes of cosine are negative sine. So if this is maybe a negative 1/4 cos x, the slopes of negative cosine would be positive sine. There are the slopes of f. If I were to plug in pi over 2, the cosine of pi over 2 is straight up and down. I'm not going to the left or to the right at all, so this is 0. I am going up 1, so I do get the answer 1/4. What about this? Cubed roots, square roots, don't worry, just rewrite as x to a fractional power. A cubed root is a 1/3 power. So let's find the slope equation. The slopes of 4x are 4. The slopes of 6x to the 1/3. The 1/3 comes down. 6 times 1/3 is 2. Subtract 1 is like subtracting 3/3. I get negative 2/3. That means my slopes are going to be 4 plus 2 over x to the 2/3. What about my slopes at 8? Well, I got 4 plus 2 over 8 to the 2/3. You are in charge of being able to do 8 to the 2/3. We did it a couple times in class. 8 to the 2/3 is the same as 8 to the 1/3 squared. 1/3 squared is the same as 2/3. The cubed root of 8 is 2. 2 squared is 4. So I get 4 plus 2 over 4. That's 4 plus a half. That's 8 halves plus a half. I get 9 halves as my answer. The slope of this at 8 is 9 halves. Let's go through the statements. At x equals 8, f of x is increasing 9 halves of a y per x. At x equals pi over 2, f of x is increasing 1/4 of a y per x. No on average. We're not talking about average rate of change anymore. We're talking about an instantaneous rate of change. Okay, some more of similar ones. I'm probably going to start by rewriting this as x to the 1/2 and rewriting this as 1/6 x cubed. I'm going to use my derivative rules for powers, make that 4 times a half, which is 2. Subtract 2 halves is negative 1/2. Going to take this 3, bring it down. 3 times a 6th is 1/2. Subtract 1, 2. Plug in 4. Maybe before plugging in 4, I'm going to write it as 2 over x to the 1/2 plus 1/2 x squared. Now I'm going to plug in 4. Gives me the slope of g at x equals 4. It's very easy to find these slope equations. So easy that we take it for granted how powerful and important it is. We know square root of 4 is 2, so 2 over 2 is 1. This is 16 times a half, which is 8. This is 9. This function at x equals 4 is increasing 9 y's per x. This is an m. Don't you forget it. This is an m. Don't forget what you have, what it means. This is the slope of the tangent. This is the first thing we've been doing with these slope equations. Plug in x, get an m. Cosine slopes are negative sine. What do you do with the 2? Nothing. 2 cosine slopes are negative 2 sine. Negative 8 sine will be negative 8 cosine. The slopes of sine are cosine. The slopes of cosine are negative sine. This is the slope equation. Let's find the slope equation at pi over 4. I get negative 2 times the sine of pi over 4 is root 2 over 2. You better know how to do that. Again, trigonometry will just show up randomly. The cosine of pi over 4 is also root 2 over 2. This becomes negative 4 root 2. This becomes negative 5 root 2's. You are in charge of being able to do that. Negative root 2 minus 4 root 2's is negative 5 root 2's. At x equals pi over 4, h of x is decreasing 5 root 2's y's per x. Now let's do some fun stuff, because we can do the visuals, find the equation of the line tangent. Okay, well, a tangent line is just first of all a line. The equation of a line is y minus y1 equals m times x minus x1. The only thing is that this is not just any slope, it's a tangent slope. This is the point on which we have the tangent slope. So don't forget, plug in x's into f's, get y's, or plug in x's in here, you get a y. This is 0. There's my x, there's my y. Plug in x's into slope equations, get m's. Slopes of x squared are 2x. The slope of 2x is 2. The slope of minus 3 is 0. Minus 0 plus 0, who cares? This is not my tangent equation. This is my slope equation. We still have to plug in 1 to get an m. A lot of times people see something that is a line, and they're like, oh, that must be my equation of my tangent line. No, this is my slope equation. Plug in x's, get m's. So I get y minus 0 equals 4x minus 1. No, I already did ours for our class. It's already up, dude.
Yeah.
Oh, you wanted to be in it?
Yeah.
You wanted a shout out? All right, so x squared plus 2x minus 3. Y equals 4x minus 1. Ba-bam. Beautiful. Now, that's just a visual cool thing. What's the important thing? This number. At x equals 1, this function is increasing 4y's per x. Okay, it's how quickly it's going up or down. All right, let's figure out the y value. Cosine of pi over 3. Stuff does not disappear on you guys. So pi over 3 is straight up. Cosine is the adjacent. It's a half. It's the tall 30, 60, 90 triangle. The adjacent is a half. So here's my xy. Plug in x into f, get y. I need the slope equation. The slopes of cosine are negative sine. Y, it just kind of is what it is for cosine slopes. Now I need the negative sine of pi over 3. Sine of pi over 3 is root 3 over 2. So I need to get negative root 3 over 2. This is an m, this is an x, this is a y. This m has meaning. Cosine is decreasing. Root 3 over 2 y's per x at x equals pi over 3. Here's the visualization of what we just found. Y minus a half equals negative root 3 over 2. X minus pi over 3. Let's see it because it's fun to see. Y equals cos x. Y minus a half equals squirts 3 over 2 negative x minus pi over 3. Bam. There it is right there. And there's the tangent slope. This slope tells us how quickly this function is changing. More practice. Gonna rewrite this
Thanks, bud.
as that. Going to plug in 2. Negative 2. Probably plug it in here. I get negative 8 times negative 3, which is positive 24, plus a half. Thanks, Mr. Messner. That's 48 halves plus a half. That's 49 halves. 24.5 I'll accept. But like most answers are going to be in this improper fraction form. Now let's find the slopes. Negative 9x squared, 3 times 3, minus 1. Negative 4x to the negative third, negative 2 times 2, minus 1. Plug in negative 2. I get negative 36 because it's negative 9 times 4. And I get negative 2 cubed is negative 8. So negative 4 divided by negative 8 is positive a half. So this is like negative 35 and a half. If you want to do that, that's fine. But be ready to change it into fractions. This is negative 72 halves plus a half, which is negative 71 halves. This is your m. This is your x. This is your y. Y minus 24 and a half. No, I need you to be ready for fractions. You need to be ready for fractions. Common denominator is very important. equals negative 71 halves x plus 2. Let's see it. Y minus 49 halves equals negative 71 halves x plus 2. Bam. It's somewhere around here, but like you can see it. It's beautiful. Decreasing very quickly. It's decreasing by 35 and a half y's per x at that location. Plugging in 3. 9 minus 1 is 8. Finding the slopes. The slopes of 3x are 3. I'm going to change this to 3x to the negative first to find its slopes. So the slopes, I'm going to change this to a negative 3x to the negative first. The slopes are positive 3x to the negative second. So I'm going to plug in 3 in here, and I get 3 plus 3 ninths. 3 ninths is 1/3. I get 9 thirds plus 1/3, which is 10 thirds. That's my n. This is my x and my y. Y minus 8 equals 10 thirds x minus 3. Let's see our handiwork. I just like doing it, honestly. Sometimes when you don't take a break and stop and see the work you've done, you don't get to appreciate it, and you're like, I have no idea what I'm doing. I don't know if it's right or not. I like doing it just to make sure I'm doing it right. There you go. Like you can see here at this point, 3, 8. Bam. There's my tangent line with its tangent slope. We got. Okay. What can f prime do for you? You can take your f prime equation and you can plug in x's and you get m's. But you can also see when your f prime equals select m's, and you could solve an equation for x to find locations on our function where we have certain slope characteristics. For example, when does x cubed have a slope that equals 12? Well, here's the slope equation. When do the slope equations produce a slope of 12? You set up and solve an equation. When x is plus or minus 2, my function is increasing 12 y's per x. Great. I could draw those tangent lines if I wanted to. Sure. Here's x cubed. I know that at 2, 8, my slope is 12. Bam. I also know at 2, negative 8, negative 2, negative 8, my slope is 12. Bam. I can see my slope is 12 here and my slope is 12 here. At these two locations, I'm increasing 12 y's per x. When is this increasing by 16 y's per x? Okay. When is the slope formula going to produce a slope that is equal to 16? Set it up, solve for x. Add 6, divide by 2, at x equals 11. All right. You will do this often. Horizontal tangents or when slopes are 0. Horizontal tangents are great because you will find locations of maxes and mins, and we will do this often. I hope you guys understand. I'm finding a location on G where my slope is 0. Now, this is the best one to find because we are finding the vertex of this parabola. We found the vertex of this parabola using calculus. We know that my vertex is where I have a horizontal tangent, right? Because it's like where the vertex bottoms out. We can see the slope is 0. It's neither increasing nor decreasing. What is that x value? 4.5. 4.5. Now, you could have actually done that remembering the quadratic formula and negative b over 2a. You could have done negative b over 2a and got 9/2. But there was no formula for finding the locations of like the humps of a cubic. So this is a great question. If I asked you, where are the humps of this 1/3 x cubed plus 5/2 x squared plus 6x graph? And you can see it. It's like, okay, we have like a hump here and a hump here. Like, what are those locations? Well, this is where calculus is easy. If you bring down the 3 and multiply by a 1/3, it just becomes a 1. If you bring the 2 and multiply by 5/2, 5/2 times 2 is 10/2, or the 2's cancel, you get 5. If you look at the slopes of 6x at 6, when will my slopes equal 0? Here's my slope equation, 1 will equal 0. X squared plus 5x plus 6, you have to factor. X plus 2, x plus 3. We get x equals -2, x equals -3. This is not a point. These are two x's. X equals -2 and x equals -3. These are the two x locations. I probably should write it out just so you don't make that mistake. X equals -2. Hump. X equals -3. Hump. Cool. Where does the slope equal -1? When do my slopes equal -1? When will my slope equation produce a slope of -1? Slope equation. When does that equal -1? Move things over. Don't have things factored set equal to a number. Have things factored set equal to 0. I'm going to factor out a 3. I'm going to factor this. And I get my two locations, x equals -3 and x equals -1. At those two locations, my slope equals -1. Ooh, when do we have a line tangent to this and parallel to this? Well, we got to talk about this word parallel. What does it mean to be parallel? Parallel lines never cross, right? Parallel lines never cross. We understand. What is a key characteristic of parallel lines? The same slope. Parallel lines equal slopes. So, parallel lines equal slopes. What is the slope of this equation? Well, I don't know until I solve for y. And I get y equals mx plus b. And I'm like, oh, that slope is 6. When does this have a slope of 6? And then I actually want you to find the equation for it. All right, so here is my slope equation. When will my slopes equal 6? I see x has to equal 6. Like I add 6 and divide by 2. Cool. Now,
She had a couple of questions that she asked Jess.
Yes, and she just came with them too, but she never asked me. Did she even do it?
we want the equation of the line. So we have this that we need all the information.
Yeah, it was.
Pay attention to what we have. We have an x, we have an m. What do we need? The y. How do we find the y? Plug in x into the original equation. 36 minus 36 minus 2 is 2. So y minus 2 equals 6, x minus 6. That kind of stakes that where you have the same slope and x value. Let me just highlight this. This m is that right there. So I'm not going to graph that just because I want a better answer. Find the equation of the lines tangent to this and parallel to this. Okay, well, this line has the slope of 16. So I'm going to figure out when this slope has a slope of 16? When will this function have a slope of 16? I'll take my tangent equation and see what x's will produce slopes of 16. And I get when x is both plus or minus 2. Okay, cool. Now that means when x equals 2, my slope is 16. That also means when x equals negative 2, my slope is 16. That means I have two tangent line equations. Y minus y1 equals an m times an x minus an x1. And I have a y minus a y1 equals some m times an x minus an x1. Wait, hold on. I have my m. I know my slope is 16. I know that because I found when my slope equation produces a slope of 16. So this m goes right here. This m goes right here. What do I need? I need a y. How do I find the y? Original equation. Plug in 2 into the original equation. I get 8 plus 8 plus 1 is 17. Plug in negative 2. I get negative 8 minus 8 plus 1, which is negative 15. So I got y minus negative 15. Hope you're not copying this down. Hope you really understand why I'm getting that, where that comes from. I am going to see this because this is something nice. We got the equation of x cubed plus 4x plus 1. I have this y minus 2 line equals 16x minus 3. This line is not tangent to this function. Let me just kind of like shrink the x's, but expand the y's. So like you can see this line is not tangent to the graph, but I wrote down two lines. Y minus 17 equals 16x minus 2. Bam. There is a tangent line that is parallel to this line. Beautiful. What about this one? Y plus 15 equals 16x plus 2. But bam, I got three lines that are parallel to each other. This first line, which is just like an irrelevant line, but it gives me a slope that I'm looking for. Then I have two tangent lines that have the slope of 16. That means my function is increasing 16 y's per x at those locations. It's like calculus is beautiful because it's like fun to see what you've done. When do these two functions have the exact same rate of change? Well, when do the slopes equal each other? Well, I got the slopes for this guy is going to be given by slope equation for this guy is 2x plus 3. The slope equation for this guy is 6x plus 6. When will these slopes equal each other? Look at that. Easy. Yeah, negative 3/4. This slope and that slope will be the same. What is the slope? Honestly, like you could plug it in and figure out what it is, but they didn't ask you that, what the slope is. They just said what x value. Same here. What will these slopes? Here's the first equation slopes equal the second equation slopes. When will the slopes equal each other? Move everything onto one side because you have x squareds and x's. Factor solve. Both at 0 and at 4, these equations have the same slopes. Now, at 0, both of these slopes are going to be 0, so that's fun. But at 4, both of these slopes are going to be some very large number, 9 times 16. Okay, last page. These last four problems, are gonna trip you up, but like then you'll be like, oh, that's not that bad. G equals ax cubed minus 5x has a tangent line at x equals 2 that is parallel to y equals 5x plus 6. What does a have to be for this to be the case? We didn't get to this example in class, but it's like something that like I bet you could figure out if you just tried. Again, we can't try to memorize how to do all these questions. There's too many different types of questions that we have to keep up with. You have to understand. So I want you to try. I literally don't want to show you how to do this problem. I want you to try. When x is 2, my m has to be 5. A is a number. 3 times ax squared minus 5 is my slope equation of ax cubed minus 5x. When x is 2, m has to be 5. When x is 2, my m's have to equal 5. This has a tangent line at x equals 3 that is parallel to the line connecting these points. Find b to make this true. How do you find the slope between 2 points? Use the slope formula. Yo, like little do you know, but every single time you find your slope equation, you're actually using the slope formula. Every single time you find the slope equation, you actually use the slope formula. It's just like the slope formula was used to develop the rule. The rule is very easy to understand and follow. Okay, m is 6. When x is 3, my m needs to be 6. When x is 3, this slope needs to be 6. Get your slope equation. That's your slope equation. When x is 3, my m needs to be 6. This is not bad. You're trying to memorize though, it's gonna be tough. What makes this tough is you actually have to find the slope by solving for y. Hopefully you guys remember like y equals mx plus b. So you have to solve for y to see the m. Or if it's in point slope, you see the m. So this m is 2. When x is 1, m needs to be 2. What is the m equation? This is the m equation for h. When x is 1, my m needs to be 2. We could actually visualize this and show that it's like correct and we got it right, but like I'm gonna just move on and give you these last 4 questions, and it's like, oh, what do I do? Mr. Messer, I thought we were done with limits. I mean, like we're never done with limits. We've been using limits every single time. You need to be prepared to recognize that this is Mr. Newton's very standardized slope formula for 2 points on F, h distance away, an x distance of h. He's making that x distance 0 so that it becomes a tangent slope. So what do I do? What do I do? You translate this question to really being what is the derivative of sine x? What is the equation of the tangent slopes to sine x? The answer to this limit question is cosine. It's essentially, what is the slope equation of sine? It's cosine. This is the same deal. This is the marriage of a limit and a slope formula. Using cosine at x, marry limit, marry slope, you get tangent slope. Cosine at x, the slopes of cosine are negative sine. These are very typical AP style problems. And they're not hard. But everybody like thinks that they have to do limit stuff rather than seeing that. Oh, this is just slope. Oh, now it's not at x. It's when x approaches pi over 2. This is the slope of cos x at x equals pi over 2. Well, the slopes of cosine are negative sine. The slopes of cosine of pi over 2 is going to be negative sine of pi over 2. Sine of pi over 2 is 1. This answer is actually negative 1. You'll see more of these on your future homeworks. This is a great question. You think this is like, what is the slopes of sine? But it's like x is approaching 0. This is actually, what is the slope of sine as x at 0? So I like to translate this to slope of sine at x equals 0. Slope of sine is cosine. Cosine x at 0 is 1. The answer to that question is 1. Oh man. It's funny, like a lot of calculus classes learn that this limit is 1, but not thinking about it in terms of a definition of a derivative. So I just made that connection. If there's a homework that you need to do twice, this is the homework. If you don't know how to set up and solve equations, if you don't know how to create tangent lines, if you don't know how to do this, like the rest of this unit is going to struggle, because all we're going to do is add more and more rules, but like ask the same questions. What's the instantaneous rate of change? What's your equation of your tangent line? When does your instantaneous rate of change equal this value? When does this function have a same slope as this function? Give me values of a or b to ensure that this function has a tangent slope that equals this here. And you have to be good at your exponent rules, and you guys stink at your exponent rules. Like, no offense, like we love you. You're great, but you are not good at your exponent rules, I can tell. So all of this stuff you need to practice, and if you're gonna do a homework again, you do this one. All right, later. Sorry. Peace.